2/3 of Andy's money was the same amount as 3/7 of Bob's money. If the difference between the two amounts of money the two boys had was $10, how much money did each have? We are going to solve this problem visually, and we are going to start with 2/3 of Andy's money and 3/7 of Bob's money. I know these two amounts are equal, and I'm going to represent 2/3 of Andy's money and 3/7 of Bob's money with 6 boxes, and 6 is coming from this 2 times this 3, and we're going to soon see why that's a good choice. So this is Andy's 2/3 of Andy's amount, 2/3 of Andy's amount, and this is 3/7 of Bob's amount. According to the question, these two quantities are exactly the same. So if 6 boxes represent 2/3 of Andy's money, then 6 boxes must represent 3/7 of Bob's money. Once again, why 6 boxes? Excuse me. 6 boxes, we take 6 boxes because 2 times 3 is 6, and we're soon going to see why that's a good choice. Okay, so if this is 2/3 of Andy's money, then this has to represent 1/3 of Andy's money. If this is 2/3, this is 1/3. So if I can put 3 more boxes, I will have all of Andy's money. Once again, if 1/3 of Andy's money contains 3 boxes, I need 3/3, so I need to put 3 more boxes here. Again, if this is 3/7 of Bob's money, this has to represent 1/7. This has to represent 1/7 of his money. Now you really want to understand this, so let's go ahead and I'm going to write it here. This is 1/7 of Bob's money. This is another 1/7 of Bob's money, and this is another 1/7 of Bob's money, and here this is 1/3 of Andy's money, and this is another 1/3 of Andy's money. Now let's try to understand why 6 boxes were a good choice. My 6 boxes could be split into 2 parts, because if that represents 2/3, I can easily find 1/3. And again, my 6 boxes can also be represented. I use 6 boxes to represent 3/7 of Bob's money, and that was a good choice because from 3/7 I could easily find 1/7 by cutting up my 6 boxes into 3 equal pieces. So that's the justification or rationale for using 6 boxes, 2 times 3, 6 boxes, to represent 2/3 of Andy's money and 3/7 of Bob's money. So based on this factor, I'm going to try to represent the entire amount of Andy's money and the entire amount of Bob's money. So note, from our previous slide, this is excuse me, this is 2/3 of Andy's money, and this is 3/7 of Bob's money. If this is 2/3, this has to be 1/3, 1/3, 1/3, and I added another 1/3. That should represent all of Andy's money. Again, if this is 3/7, this has to be 1/7, another 1/7. So I have 1/7, 1/7, 1/7. I have 3/7. I need four more 7s. 4/7, 5/7, 6777. So this must represent, the second line must represent Bob's entire amount. So now we have the pictorial representation of Ann's entire amount and Bob's entire amount, and we can clearly see that 2/3 of Andy's entire amount, the top one is for Andy, and the second one is for Bob, is equal to 3/7 of Bob's entire amount. The picture clearly shows that. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 boxes representing Andy's entire amount, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 boxes representing Bob's entire amount. Now the difference between the two amounts of money the two boys had is $10. And that tells me this has to be $10. And that tells me that each square must be worth 10 divided by 5, because there are 5 squares that are worth $10. So each square must be worth $2. Now how much money did each have? Well, I have altogether 1, 2, 3, 4, 5, 6, 9 squares for Andy, and so Andy should have 9 times 2, $18, and Bob has 9, 10, 11, 12, 13, 14. Bob has 14 squares, so he should have 14 times 2, $28. So my answers are Andy had $18 and Bob had $28. Now if you want to work backwards and check your answer, it works out pretty neatly, because 28 minus 18 is 10, and if you have 9 boxes here, I'm going to write 9 here in green. We are just checking our answers. I have 9 boxes, and here I have 14 boxes. Okay, oops, I'm sorry. I'm going to write here. I don't want to get out of my screen. Okay, now check it out. 2/3 of 9 is 6, and 3/7 of 14 is also 6, and they're equal. So my answers are $18 and $28.